This time we will start chapter 1 of our statics class. Chapter 1 is all about introduction, very basic stuff. So let us start. So our class is statics. Let us see where statics came from. So statics is actually a part of mechanics. Now other question, what is mechanics? So write it down. Uh, So mechanics. What is mechanics? Mechanics is like the result of the force on a body. Whenever we apply force on a body, what will happen? That is called mechanics. So the action of force and its resultant on a body is called mechanics. So mechanics typically we classify into three categories. One is a rigid body, one is deformable body, one is a fluid type body. So it has mainly three branches. So one is a rigid body, other one is deformable body, and other is fluid mechanics. So what does rigid body means? Rigid body means the body is so rigid that it will not deform. Say there is a building here, there is a, say this two column, I have a load here, uh, my support here is this. So this is a some part of a building, there is a load here, there is a load here. Then if the load is very small, that this beam does not deflect, that we can consider it is a rigid body. Even if this column does not contract due to the load, we can consider it is a rigid body. That is called rigid body. What is deformable body? If my load is so big and this beam or column bends, this column shortens due to the load, we can call it is a deformable body. So rigid body, say if I apply load, what is the load in this column? What is the load in this column? If we are concerned about the load only, not the deflection, it is called a rigid body mechanics. If we are concerned, say this beam will bend, then what is uh, the deflection of the beam? If we are concerned about the deflection, we will cover in the deformable body mechanics. And if my body is fluid, water, oil, then we'll cover it in a separate class. So statics is part of rigid body. So rigid body has again two parts. One is statics, other is dynamics. What is statics? Statics means if my body is static, if my body does not move, or if it moves at a constant speed, that is also called statics. Dynamics is if the body has some force on it, then it will accelerate. What is that? Say the speed of a car at some time is 10 miles per hour, after sometimes it's 20, after sometimes 30 miles per hour, after sometimes 40. That means speed is increasing. So that is that discussion is covered under dynamics. Statics is the body is not moving, even though if it moves, it will move at a constant speed. Mostly statics means actually not in motion, a structure like this. So that is the overview of mechanics. So in this class we will do this, only this statics. In another class you will learn dynamics. In another class you will learn deformable body. That is typically we call strength of material class or mechanics of material class, another class. Fluid mechanics we cover it in another class. So in one class we cannot do one. To cover mechanics we need minimum 4 classes. One is statics, one dynamics, strength of materials, fluid mechanics, and its advances. So that is the definition of mechanics. And where is our class? So, okay, what are the basics of this class? This statics is dependent on Newton's laws of motion. You know that Newton has three famous laws. Law number one: if you do not apply force on a body, it will not move, or it will not start to move. Or if a body is in motion, if you do not apply force on it, it will not change its motion. That is the Newton's first law. That means if I do not apply force on a body, it doesn't change its motion behavior. If it is at rest, it doesn't start motion. Rule number two, or law number two, we call if we apply force on a body, it accelerates. There is an equation that the applied force is proportional to the acceleration. That's rule number two. Rule number three is if I apply a force on a body, the body will react on me with an equal and opposite force. So that is rule number three. Statics is dependent on rule number one and rule number three mostly. Rule number two, we use it in dynamics class. So dynamics is dependent on rule number two. Statics is dependent on rule number 1 and 3. Okay, so that is our basic. So statics, this class actually started several hundred years ago when Newton gave us the theory, and still now we will use that theory. So this class is not like brand new, so it is very old, several hundred years old, maybe 400 years, about 400, more than 400 years old. So whatever we will learn is 400 years old knowledge, but we need it, and this is a very basic class for any engineering. Okay, that is the basics. Then what do we need to study? Some quantity. So we typically measure three quantities. One is same mass. Mass is the quantity of an object. Then is time. Time is the the span of an event. That's called time. And also length. Length is the linear dimension of something. So we measure these three things. So we need to know the unit. When we measure something, there must be some unit. What are the units? Say and types of unit. So broadly we use two types of unit. One is SI. SI means systems of international. It is international unit. Other is United States customary. So United States customary system, or simply sometimes we call FPS. FPS. So what is FPS? Foot. This is pound, or right, pound. This is second. So USCS, United States Customary System, we use foot for length, pound for our mass. In short we write LB. In short we write LB as pound, and time in second. That is USCS system, or FPS, foot pound second system. In SI, system of international, we write meter for our length, kilogram for our mass, and second for our time. So that, okay, right here, that is for not mass, that is for our length, this is for our mass, this is for our time. Same thing, length, mass, time. But there is a problem here, this mass, pound. Now before going there, so kilogram is a mass, it is not a weight. And also weight and force is same thing, so do not get confused. Weight means the force on an object by the gravitational acceleration, that is called weight. So it is one kind of force. So force and weight is same thing, just like force means if we apply some force, that is force. But whatever the gravity applies on a body to the ground, that is called gravitational force. So weight is actually gravitational force. So weight and force same thing. Kilogram is a mass. It is not a force. It's mass. Mass means the quantity. If I want to convert into force, force or weight, how to do it? So say weight is mass times the gravitational constant G. You know it, gravitational constant, or W equals mg. So do not get confused between mass and force. Mass is the quantity. It doesn't sense. If you go to moon, the m will remain same. Sometimes we get confused. This m is meter, but for mass we also use m. That is a confused term. So do not get confused now. Just clarify now. This is m means mass. So the weight of a body, mass times gravitational constant. So if you go to moon, this mass does not change. This g, gravitational constant, it changes. So the weight of a body changes. The weight of a body in America and the weight of the same body in say Africa or Asia or Australia, wherever you go, might change depending on the g value. You know that g is not constant. That's a different discussion, not now. So okay, what is the unit of weight? Unit of weight is again weight and force, same thing. Yes, weight and force, same thing. So its unit is Newton in SI unit. In SI unit, the unit is Newton. Uppercase N. Why uppercase? Because it is the name of a person. Newton. M is kilogram. G is meter per second square. Meter per second square. That is for SI unit. What about US? US unit. In short, we call US unit. Here, what is pound? Is it mass or weight? That is a big confusion. So this is the time to remove your confusion. Pound is weight. It is not mass. But we use pound as the unit of mass. So in US unit, typically we use pound for both mass and weight. It is the confused term. But actually pound means pound force. It is a weight. So we should write actually this. We should write this, but we write LV. Again, pound force and pound, same thing. It is weight. It is not mass. It is weight. I know you will make this mistake many times in this class, in our next class. So if I make some room, so pound force and pound is same thing. It is simply, it is weight. It is weight. Do not make this mistake. So if you want to convert, the pound equals pound mass times G. Similar to this equation, weight equals mass times G. In SI unit, G is 9.81 meter per second square. In US unit, so pound force or pound, same thing, equals pound mass times 32.2 feet per second square. So G is 32.2 feet per second square. Actually 32.174 something, but 32.2 is a good number. Again, this is pound mass. Sometimes we call this slag. Sometimes we call this slag. So slag and pound mass, same thing. Pound and pound force, same thing. So pound equals pound mass times gravitational acceleration in feet per second square. Again, do not use 9.81 here. It is SI unit, it is US unit. So hopefully you understood what is pound, what is pound force, what is pound mass, what is slag. Very confusing term. Now let me ask you a question. So when you go to Walmart, buy something, if they say it is 2 pound, that 2 is actually weight, pound force. But if you go to Walmart, buy something and they call it is 2 kilogram, that kilogram is a mass. So even if you take your weight on a scale, if you get your weight in kilogram, it is mass. If you get your weight in pound, it is a force or weight. So hopefully I made you clear about the unit. If you have more question, go to book, ask me, go to Google, whatever. Yeah? So unit system is done. Again, unit system very important, because whenever you solve a problem, you need to report the answer. Next topic in this class maybe rounding. So rounding. Now rounding is a confusing term again, because uh, there is no unique answer in it. Like means how should you round, or let us start the rounding rules part. What are the rounding rules? Say there is a number 2.756. There is a number 2.756. I need to round it to 2 into 2 decimal places. That means I need to take the 6 off. What to do? Now there are many ways to round up. The best way, actually 3 ways we can do it. 3 ways we can round up. One is, if the last number is 5 or higher. If the last number is 5 or higher, just increase this number by 1. So 2.76 is the answer. That is one way to do it. Other way, number 2, we like to see even number. Say even number, that means if I follow this rule and if the product is a even number, we like to do it. So that means after doing this, we are getting 2.6. It is a even number. So we like to do it. That is another rule. So if the number is like this, 2.746, or say 2.726, this number is 5 or more than 5. So if I do it by this rule, it becomes 2.73. But this number is not an even number, it's an odd number. Sometimes we do not like to see odd. In that case, if we use 2.72, is not a problem. But we do not use this rule so much. This is more popular. Other rule is rule number 3. If we do this or this, if the end digit or the last digit, say here or here, if the last digit is 5, we do not want to move it. Say 2.756. If we want to keep 2.75, it is okay. Why? Because we like to see here 0, 5, this kind of like milestone number. So 5, it sounds better instead of 2.76. But these two rules are not very popular. This is the most popular rule. Whenever the last digit is 5 or more, remove it, increase the previous digit by 1. That is the most popular. So rounding is done. Then how many digit or significant figures? That is significant figures. That means there is a number 2.756. Should you write 2.76, or should you write 2.8, or should you write 3? Okay, so that is called like expressing into different significant figures. So do you want 3 figures after decimal, or 2 figures, or 1 figure, or even no figure, round number, or put it like this? Which one you will choose? That is another question. There is no unique answer. There is not a single answer. It depends on situation. Let me explain the situation. If I ask your age, how old are you? You will say 23, 22. Okay, so 20, say 23 is an answer. Now, if you are two friends and I need to know who is senior or who is older, then you are 23. If I ask your friend, he also told he is 23. That means this whole number is not giving me answer. Then I should go to months. Then I asked you, you told 23, 6 months. That means 23.5. I asked your friend, he told he is also 23, 6 months. So again I didn't get the answer, who is older. Then I should go to days. Even if the days is same, I should go to hours. If the hours is same, I should go to minute. So this is a rounding up. There is no rule. It depends on the situation. So another example. Say when you are taking the weight of a gold. Gold is very small, very precious. In that case, we can go to 1.00278 gram for gold. But if you take the weight of stone, which is not so costly, this amount of stone is only $20 something. In that case, we will not go by, even for stone, we will not go by gram, we will go by, say, pound. Even pound is not so popular for ton. For stone, we go by ton. 1 ton is $20 like this. So it depends on the situation. Now, other question. It means that I confused you. When you will solve a problem, what significant figures you will use? I should give you the answer. Very short answer. Whatever the problem gave you, if the problem gave you into two significant figures, you should use two significant figures in the answer. That is the very smart and shortcut. Say in a problem they gave a number 1.67 pound. In a problem, after solving whatever you get, you should do into two significant figures. If the problem gave you into round number, or round number 1, everything is round, you can express it into round number. That is the very shortcut answer. And in engineering, when you will go to senior level class, there will be like big problem, many steps. So do not round up in every steps. So in every step, take some decimal, take some discipline, take some discipline. At the final stage, do some round up. That is a smarter way, or that is the ideal way. If you round off in every step, then your answer will be way off. Hopefully you understood what I wanted to tell you. The next topic in this class or in this chapter is support type. Support type, or even types. Support types. Support means support is, say if there is a beam, say this is a beam and it is supported by 2 columns. So there is a beam supported by 2 columns. Now here, what is the type of support? What is this type of support? So support broadly 3 types. If you go more, 4 types. If you even go more, 5 types. Typically 5 types. If you learn 5 types, that should be good enough. But broadly it is 3 types. One type is roller. Second is pin or hinge. Pin or hinge. Third type is fixed. Fourth type is, say, link. Fifth is rocker. So 5 types. Okay, what is roller? Say here there is a column here, beam here. So this is my column, this is my beam. If I just place my beam on top of the column, in that case what will happen? This beam can easily move. That kind of support is called roller. So instead of showing the column, I can show like this. So this is my beam. I can put a wheel round here and place it like this. Then what will happen? What does it mean? It means this cannot move this way. In this way, this beam cannot move because there is a support here. But it can move this way or this way. That is called roller. So it can move this way, but not this way. So roller support restrained your member in one direction, only vertical direction here. So we express this kind of support, roller support, using a circle, and there is some line and some dash. Sometimes we express this way also. So there is a triangle here, put some wheel, and then a line, and then several dash. This symbol is typically means the support, some soil, this kind of support. So this and this both are roller. What does it mean? My beam will not go this way, it can go this way. So that is roller. Now second type, pin or hinge. Pin or hinge. Say I have a beam here, my beam, I have my column here. What about if I insert a pin here? If I insert a pin here, or there is some reinforcement here that go up to this, then what will happen? This beam cannot move this way, cannot move this way. So both way it is restrained, but it can deflect very easily. It can deflect, that's not a problem. But that means if the support is this, it cannot move this way, it cannot go this way, but it can twist a little bit. That is called pin or hinge. How do we express it? Typically this symbol, a triangle and some hash. So this is called pin or hinge. So it cannot move this way, it cannot move this way or this way, whatever. Yeah. So it cannot move this way, it cannot move this way. That means it has two unknown reaction. Other is fixed. Fixed means if my beam and column is monolithic, say this is my beam and this is my column. So it is casted monolithic. It cannot move this way, cannot move this way, cannot move this way. Even it cannot even twist because it's so rigid and monolithic. So in this kind of beam, we will express it by this symbol. This symbol is for fixed. So it cannot move this way, it cannot move this way, even it cannot twist. So this beam cannot twist. This support will restrain. So that is called fixed. Link. Link is, say I have a column here, I have a beam here, it is pinned here. If I apply some load, it might bend. What can I do? I can insert another bar here, say a cable. I can bring a cable here. That can be considered a link. The link support carries some force along the member. It is not pinned, it is not fixed, or something. We can do something else. We can insert some other strut here. We can insert a strut, strut, we can insert. So this is also a link because it has an axial force. It will apply axial force. That is called link type support. So it applies a force along the member. It applies a force along the member. Along the member. That is called strut. Sorry, link. Last is rocker. Rocker is similar to roller. Similar to roller. Say I have a column here. If I insert some objects, a sometimes of object, and then place my beam. Sometimes you will see this kind of support. In fact, in your book there is a figure, a real figure from I-25. I took this photo. So this kind of support, similar to roller, it can go this way, but it cannot go this way. Even sometimes we make it larger. Larger means my soil is here. I placed a bar here, and then placed my beam. Place my beam somewhere here. So this support can be considered a rocker, because even if you consider this support like similar to this roller, is it a problem? No. So rocker, roller, same thing. So hopefully I tried to explain what is support, different kinds of support. Other topic in this chapter is load type. What are the different kinds of load? Several types of load, typically four. Let us go one by one. First type of load is called concentrated force. Say I have a beam here. Say my support is column here. Say I have another beam. Another beam went that way. Another beam went that way somewhere. So if this beam will apply some load on this beam. So this beam will apply load somewhere here. But this area is so small that we can consider a single load only. If my load area is very small, say I am standing on the ground, my two legs are applying some force on the ground. So I can consider it two concentrated load. I am applying two concentrated load on the ground because my load area, my foot size is very small. That is called concentrated force. Other kind of force is if say the self weight of the beam, the self weight is uniformly distributed. That means the load on this beam is very homogeneous. We call UDL, uniformly distributed load. That means my load is distributed uniformly. So sometimes we call UDL. Sometimes we call this load rectangular load. Rectangular load. Sometimes we call rectangular because this is a rectangle. This is very common. This load is very common. Other kind of load is okay. Other kind of load is say this might be load here is 0, but load here is very high, it is uniform, this kind of load. So this is my beam. My beam, roller support, fixed support. My load is this kind of load. My load is this kind of load, triangular. So we call UVL, uniformly varying load, or triangular. So triangular load or uniformly varying load, that is another kind of load. So uniformly varying, it is varying uniformly. Other kind of load might be concentrated moment, not force. Say other kind of loads, say I have a beam here. Say this is a beam column, so I have another beam here. Who knows? If there is a load here, if there is a load here, so this load will try to twist here, right? Twist. So I can remove this load, I can remove the and place a twist here and a vertical load here. So this is called moment. You will learn more about moment in the next chapter. So this kind of load is called concentrated moment. Concentrated moment. Moment means whatever causes twisting. So twisting, that is called concentrated moment. So hopefully I covered everything whatever is required to study statics. Let me revise. So I defined mechanics, and then I showed you where statics is coming. Then I discussed the unit system. Then I discussed support type, load type, and something else, rounding rules, when to round. So these are some basic knowledge we need to study statics. So in next class we will start our next chapter, which is from core statics. So okay, see you then.